Alright, this is going to be similar to our discussion on square roots, but this is going to involve just cube roots, fourth roots, and it applies to any root you want to take of any number or expression. So let's start with the cube root of 1728, 1728. Now if I don't automatically know the cube root of 1728, I can do a factor tree, just like I did with the square roots. Right? And when I look at 1728, and I add up the digits, I get 18. Well, that means that 9 goes into 1728. You simply add up the digits, and if that number is divisible by 9, then your number is divisible by 9. So 9 goes into 17 one time with 8 left over, and 82, 9 goes into 82 9 times with 1 left over, and then I have 18, and 9 goes into 18 2 times. So I have 9 and 192. Now 9 is a perfect square, but it's not a perfect cube. So I'm going to go ahead and break it down into 3 times 3. Now 192 looks like a number that's probably divisible by 4, so I'm going to try 4. Alright, so 4 goes into 19 4 times with 3 left over, and then 4 goes into 32 8 times. Right, 4 is a perfect square, but it's not a perfect cube, so I'm going to go ahead and break it down. And then 48 can be 8 times 6. Now 8 is a perfect cube. 8 is a perfect cube, so I'm going to leave 8 the way it is. Right, and then 6 can be written as 2 times 3. So now I have all prime factors except for my 8, which is a perfect cube. And so we're going to leave him like that. So when we take the cube root, we have 1, 2, 3 2s. We have 1, 2, 3 3s. And we have our 8. Well, I can take the cube root of each one of these. The cube root of 2 to the third times the cube root of 3 to the third times the cube root of 8. This is what we're looking at, all right? Well, the cube root of 2 to the third is just 2. The cube root of 3 to the third is just 3. And the cube root of 8 is 2. So when I multiply, 2 times 2 is 4, 4 times 3 is 12, and I get that 12 is the cube root of 1728. All right, well, let's look at the cube root of this one. Now we're throwing letters in, all right? But I can take the cube root of 8, and I can take the cube root of any variable that's raised to a power that can be divided by 3. So the cube root of 8 is 2. The cube root of x to the 6th is x squared, because 3 goes into 6 2 times. So I've got 2 x's. And then the cube root of y cubed is just y. So this one simplifies to 2x squared y. Right, you can do the same thing with fourth roots. And this time we're doing a fraction, right? So I've got the fraction all underneath the single root sign. And before I begin, I notice that 81, if you don't recognize 81 as something that has a fourth root that you know, then you can do a factor tree on it. But I recognize that I can take the fourth root of 81 and the fourth root of 16 and the fourth root of y to the 4, but I can't take the fourth root of x to the 5th or of x. However, I can simplify this fraction before I begin. So the fourth root of 81, and then in the bottom I have 16 y to the 4th. But look, the x to the 5th over x results in there being an x to the 4th in the numerator. So now I'm taking the fourth root of 81 x to the 4th in the numerator, and I'm taking the fourth root of 16 y to the 4th in the denominator. Well, the fourth root of 81 is 3, and the fourth root of x to the 4th is just x. The fourth root of 16 is 2, and the fourth root of y to the 4th is just y. The fourth root would be just like the third root. It takes 4 numbers multiplied by the 4 of the same number multiplied by itself to get this number. And if I multiply 2 by itself 4 times, then I get 16. Same thing for the y, the 3, and the x. So this simplifies to 3x over 2y. Now, in this fraction, I've written them separately, but I'm going to need to combine them because I cannot take the fourth root of any of these things, not any of them at all. So let's write it as one fraction, 243 a squared b to the 10th over 48 b to the negative 2 a to the 10. Now, let's look at the numbers first, all right? Neither one of these is a fourth root. I may not know that about the 243, but I know the 48 is, I can't take the fourth root here. So I'm going to see if I can reduce them. Well, I know that 48 is divisible by 6 and 8 and 3. But it's not divisible by 9. But 243 is divisible by 3. So let's divide both of these by 3. If I divide 48 by 3, I get 16. If I divide 24 by 3, I get 8. And then 3 by 3, I get 1. So I now have the fourth root of 81 over 16. Now, let's look at the letters. So A is being squared here, and it's being raised to the 10th here. So those two A's result in an A to the 8th in the denominator. But the B's, I have a B to the 10th in the numerator and a B to the negative 2 in the denominator. So I'm going to be able to move that B to the negative 2 up and make it a B to the positive 2. So I've got B to the 10th, B to the 2. Well, this means that I have the fourth root of 81 B to the 12th over 16 A to the 8th. All right, I can take the fourth root of all of those. The fourth root of 81 is 3. The fourth root of B to the 12th is B cubed. Remember, 12 divided by 4 is 3. So I have 3 sets of B to the 4th. And then the fourth root of 16 is 2. And the fourth root of A to the 8th is A squared. 8 divided by 4 is 2. So this is my simplification for that fraction. And then, of course, just like the square roots, we can take the cube root of decimals in a similar fashion. So I can write this as the cube root of 27 over tenths, hundredths, thousandths, 1,000. Well, I can take the cube root of 27, and I can take the cube root of 1,000. The cube root of 27 is 3. The cube root of 1,000, there are 3 zeros, so the cube root is 10, and my answer is 3/10. If I want to, I can write it as a decimal, but I don't have to. All right? But you could also work this problem by writing the cube root of 27 times 10 to the negative 3. Now, if you're working with cube roots and fourth roots, you probably do understand that these are fractional exponents. So I'm simply raising all of this to the 1/3 power. Now I'm going to rewrite the 27 as 3 to the 3rd, and then I've got my 10 to the negative 3. So I'm really raising 3 to the 3rd and 10 to the negative 3 to the 1/3 power. Well, 3 to the 3rd raised to the 1/3 power. When I multiply these exponents, remember that's the exponent rule. When raising a power to a power, you just multiply the exponents. When I multiply 3 times 1/3, the 3's cancel, and I just get 3. When I multiply 10 to the negative 3, when I multiply that negative 3 times 1/3, I get 10 to the negative 1. So I could write my answer this way. But 3 times 10 to the negative 1 is 0.3, so I could write it that way as well.